Welcome. This is a very basic overview of CNC pockets and contour cuts. This here is a shield that I made for my daughter, but it just really to show how we can use our CNC machine to cut out for precision. First thing we have to do is set up our job. Clicking here, this yellowish goldish box, this is to represent the stock, the piece of wood we're going to put in our machine, therefore to cut out this shield. Our milling operation, our operation type is milling. And now we have to set up our model orientation. This is setting up where our X, Y, and Z axes is. To set this up, you want your Z axis pointing away from your part like you see here. This is the direction the bit is going to come in and cut out our part. If for whatever reason our Z-axis was upside down, you would not have a positive result. To set your Z-axis pointing up, click any vertical edge on your part and you should get your Z-axis to flip upwards. If you need to, you may have to flip the Z-axis here. Now you want to orient your X and Y axes. I have my X going from left to right, which is the orientation I want. I could flip it to have it go in that direction, but then when I cut out my part, it would look upside down. So I'll have my X-axis going in this direction. Lastly on this tab is we want to do our stock box point. Since I'm going to be putting in a rectangular piece of wood, I can easily find the middle of that rectangular piece of wood. So when I click here for my stock box point, I'm going to click in this middle blue dot because that is where I want the CNC router to read 0, 0, 0. Let the computer know what is my model, and now I'm ready to move on to my next tab. This tab is to actually represent the size of the wood you're going to put in the machine. So along my X-axis, my piece of wood is going to be 11.5 inches. Along my Y-axis, going vertically on my screen here, my piece of wood is going to be 12 inches. And then the depth of my wood, my Z, our stock here, is 0.75 inches. Now if I look at this piece of wood, there shouldn't be any gap between the bottom and the top because I'm not facing anything, and I'm ready to cut a piece of wood just like this. Go ahead and click OK, and we'll move on. Our first operation has to be our pocket cuts. Just on a side note, we cannot do this edge right here on a pocket cut. It is going to round that corner a little bit because we have a round bit coming around here going like that, which is fine. Inventor will take care of that fillet for us on its own. Because my two cuts here and here are of different depths, I have to do them as a different operation. I'll go ahead and start my 2D pocket and select my tool. We use a 1/4 inch flat mill bit. Easiest way to find this, if you expand the by type folder and go to flat mill, I'm going to scroll down, or in this case I'm going to scroll up until I get to 1/4 inch flat. All of these will do just fine. I prefer to use the bottom one that most closely resembles the bits that we use here in class. Go ahead and hit select, and I'm ready to move on to my next tab. For wood, we go ahead and leave these speeds just like that. It's not as big concern. When we get into metal or harder things to machine, we'll have to talk more about this. My next tab is the geometry. What is it that I want to cut out? Since I'm doing a pocket cut, I'm going to select the bottom of my pocket. I'll start with this cut and then I'll go in and do the M in the middle. Good. Next tab is the heights. This is the height of my bit as it goes. If I rotate this upwards, you can see the various heights with clearance height, retract height, feed height, and top height. My top height is either my stock top or my model top. The way I set it up, they are both the same. I'll go ahead and be model top just to be consistent with how I set up my CNC. And then my bottom height is my selected contour. It's where I selected for the base of my pocket. So it's going to cut from the top of my model down to this groove. Good. I'll go ahead and go to my passes tab. On my passes tab, I want to take this out using multiple depths. I don't want to cut this out in one pass. That's too deep of a cut for our routers. I'll select this multiple depths box, and my step down. how much is it going to move down as it cuts the wood? I'm going to use 0.1. Because I'm using a 1/4 inch bit, this is less than the radius of the bit, therefore it's within our acceptable range. And lastly is this linking tab. On this linking tab, all I do is uncheck keep tool down. Go ahead and click OK and see that it generates a tool path for our part. These blue lines is the path this tool is going to follow right here. Because I have a second pocket cut, I'm going to lay this one out as well. These could have been done in either order. My tool is the same. My geometry, my pocket selection, again, the base of your pocket cut. My heights tab, stock top, or model top, because in this case it's the same. I like to use model top as a consistent tool. And then my bottom is my selected contours, which I selected the bottom of my pocket cut. On my passes tab, again, I always want to go multiple depths, and I'm going to change this to 0.1, or as long as it's smaller than the radius of the bit. And on my linking tab, uncheck keep tool down. Let's go ahead and click OK. And this is the path that it's going to take to cut out the M here. Lastly, I'm going to cut out my 2D contour. This is actually going to cut out my part. Continue using the 1/4 inch flat mill bit. As I go to my geometry, I want to select the bottom edge. And then I'm going to verify that this arrow is on the outside, so my bit is going to be on the outside of here. If you need to switch that, if you click on the arrow, now your bit is on the inside, which is not what I want. On this case, I'm going to use tabs. I'm going to perforate my part so that it doesn't all come out at the same time. One thing about Inventor, it estimates the size of tab that it feels would be appropriate for your part. I like to make mine a little larger, so I'm just going to make this at 0.2 as well. Therefore, my tabs will be nice and strong, and I don't worry about breaking my part. On my heights tab, again, I go with model top and selected contours because I selected the bottom part, the bottom of my part here. On my passes tab, as always, multiple depths, and I'm going to change this to 0.1, which is within my tolerance of a 1/4 inch bit. And lastly, on my linking tab, uncheck keep tool down. Let's click OK and see how this works. As you can see here, these are the various passes, going down 1/10 of an inch every time and lifting up here to leave my tabs so it doesn't cut that out. I'm going to go ahead and left click on setup or right click on setup and go into the simulate. I just want to verify that it's going to do everything I want. I'll go ahead and click play here to see this bit. Everything looks into the correct orientation. You can check the stock box where you actually see it cut out a piece of wood, and you could speed up the simulation by dragging this dot down here just to verify that everything is going correctly. I'll rotate it up. You can see my tabs here, so my part will not have any spin out. Tabs all along here. Looks like my depths. As we talked about earlier, it does round this corner for us and the like, but that's okay. I'll go ahead and close this. And lastly, I'm going to right click on setup and go to post process all. The file path that we need for this is emc.cps. I believe the default setting is achromatic, or the first one on the list. Our language is emc.cps for our CNC machines. Our output folder, this should be the location of your flash drive. If you have one, I don't have one in my computer right now, but I would go ahead and put it inside my flash drive to take it over. I'm going to go ahead and click Open Documents, and then this is the default program name or number. You can leave that there the same, or I can say Maddie Shield, because this was the shield I made for my daughter. I'll go ahead and click Post, and it's going to put Maddie Shield inside my Documents folder. You want to make sure that this is a flash drive so you can take it to the routers. I'm going to go ahead and click Save, and it's generating the G code. I always scroll through this. You should have a couple hundred lines of code for most things. This is the programming language that our CNC routers need to go ahead and cut your operations. This looks pretty good. It looks in depth. If it's only 50 lines of code or so, unless you have a really simple part, you probably made a mistake somewhere on the post process. I can go ahead and close this box right here, take your flash drive over to the CNC router, and set it up and begin cutting. Thank you for your time.